All right, let's have a look at 24. Oh, I hate teaching in a mask.
You should have started teaching it.
Okay, with this type of question, girls, look at the diagram, look how I set it up. I don't like how they've drawn the diagram. You usually want to draw the complex numbers as an actual vector. See how they put a dot and they put B and it brackets Z2. You usually want to write the point at the end, but you want to label the vector on the line. That's like one of my tips. I'm going to start making silly mistakes, aren't I, with this? I can already feel it. Alright, so set it up like this. Now, let's read the question, right? Z1, let Z1 be a complex number. So we've got Z1 there. And then you've got let Z2 equal to, so we've got Z1, and then to get to Z2, you got to multiply Z1 by that, okay? So just keep that in mind. So what that means is to go from Z1 to Z2, they're multiplying by that. But do you guys remember what that means? If you multiply by that, what is... Okay, you know what? I'm getting a bit too ahead of myself. Let's look at the question first. Sorry. The diagram shows points A and B. Let's look at the question. Explain why, or show why, OAB is an equilateral triangle. So if I want to prove this, what properties do we know? Well, we need pi over 3 for the angles, and we need the lengths to be the same. So in this case, we need to prove the modulus of Z1. Yeah, does that make sense? So if we can show this here with the information we're given, we're done with that question. It is worth 2 marks. Okay? So in order to do that, girls, do you guys remember what this Euler formula in mod alg form is? So if you remember, when we have this, what is that?
Yes.
But do you guys remember what the R was, the modulus?
No.
It is. It's just 1, right? So then what's it here? Yeah, it's just 1 or just without it. That's right. So this is the technique that I want you to go to bit with C. So that's that times Z1. And that's basically that interpreted as that. So that, what does that mean? So to get from Z1 to get to Z2, you're multiplying by this, which means when you multiply by a certain complex number with an angle, it means you're getting from one complex number to another. Can't talk. You're getting from one complex to another by a certain angle. Yeah? Okay, so what we can, so we've basically by looking at that, we've shown that's pi over 3. Now, how do I show this bit though? You don't have to show it per se. You can kind of just look at it and tell it is, but can you actually tell that Z1 and Z2, the length are the same by looking at this? How do you tell that? Okay, I'll give you a hint. And this might be the tricky part.
Oh, it's 1 times 3.
Yeah, no, it is. Okay, you know what? To make it explicit, let's let Z1 equal to, let's say it's that. Then, what is Z2? It's that. So really, it's just cis pi over 3 times by Z1, which is r cis theta, right? From here, what's the modulus of Z2? Yeah, it's just r. Yeah, because this is just 1. The modulus is 1. This is r. Yeah, and here, and similarly, yeah? So, yeah. So it's nothing tricky. It's kind of hard to see that or show that, but yeah. So because these two lengths are the same, that's basically enough. Yeah, it is, because if we now form a triangle, if these two lengths are the same, these two angles must be the same, and using angle sum of triangle, these guys must be also 60 degrees. Yeah? So, yeah, that's all it is. I just thought I'd go through it because the solutions are garbage, and it's just doesn't help looking at the solution, so that's all it is. All right? Now, I hate wearing a mask. Second part, we've got to prove is equal to this. Look, I'm not going to go through too much on this, but it's just algebra work, and I don't really like how solutions does it. It's just algebra work, girls. Z1, we let it equal r cis theta. So in this case, that'll be r squared cis 2 theta times by Z2. Oh, what's Z2? How would I put this together? What is the angle? If we multiply two complex numbers, you add the angles, yeah? So then here, if I square it, it'll be r squared cis 2 times the angle, but I'll just write it like this. Yeah, so I can put it inside, yeah? So 2 theta plus pi over, 2 pi over 3. So basically, figure this out, and then you'll find that it's equal to this side when you multiply Z1, Z2 in this case is r cis theta times r cis 2 theta, oh not 2 theta, sorry. Z2 is just theta plus pi over 3. So yeah, work from that side, work from that side. It is a bit of algebra work, but you eventually get the same thing on both sides. Okay, so that's how you do this question. And it is worth 3 marks, as you can see. It is going to take some work, but that's all it is. It's not hard, okay? A represents a complex number as well, okay? Now, you're given all of these lengths are equal, and they're all equal to 1 in the description given. This is very fun. They've also given you this. W is equal to cis pi over 3. What you need to show is prove Z2 is equal to WA. All right? Now, what makes this question tricky at first glance is, first of all, before we do anything, let's label inside this diagram what we know. What can I fill this diagram up with if they're all equal? Angle, sorry, I just said it.
360 divided by 20.
Oh, let me just write that. I mean, that's the first thing that I did when I looked at the question. I mean, I just wanted to fill in the obvious. So we know all of this is 60 degrees because the equilateral triangle. Now, let's have a look at the question though. I hate this. We need to prove Z2. So our focus is Z2.
Now Jim looks aside at the office at the camera every time.
Huh?
Now Jim looks aside constantly at the office. You're basically doing it every time I do this.
So we need to prove Z2 is equal to, now, A is involved. Okay, so we need to prove A times W is equal to Z2. I think you girls got it, that's fine. Okay, as you can see, to get from A to Z2, you're just multiplying by pi over 3, which is W. Okay, that was obvious to you girls? Oh, amazing, that's great, okay.
You just overcomplicate things.
Or I did at first.
No,
Okay.
yeah, I think you went in because it looks hard, so you just thought it would be hard.
Yeah, because when you look at it, it does look tricky. Maybe when you see it up on the board, it just makes things clearer. Is it like that? When you look at it on the paper, it looks confusing as hell, but when it's up on the board, it's like, oh, it's easy. Is it like the case? Yeah? Okay. So yeah, well, it's not hard. So how do you even put that in writing? By geometry?
I know the answer. Okay.
Wait, hold on. Let me see what I wrote. Okay, you write Z2 is equal to, write it in terms of vectors. So OR, so that's a vector, and then times cis pi over 3. It's just another way of rewording that, and then you could basically say
That's
this.
so stupid.
Yeah, it is. And how much is that worth though? 1 mark.
No, but like, that's not even that, like, okay.
Yeah, but actually a lot of students actually find this type of questions tricky.
Yeah, because like it's hard to quantify something.
Oh, but you know why it's also tricky is if I didn't label the pi over 3 everywhere,
Yeah.
it may have been hard to see.
Yeah.
So maybe I gave that away by first doing that for you girls already. Maybe I should have held that off. I hate teaching in a maths before, I know. You just don't.
Masks. COVID outbreak.
All right, let's look at the second part. I'll show that Z1, Z2 is equal to A squared. I don't really think I have to go through that, but let's get the expression for Z1, Z2, and I'll let you girls do it on your own. We know we know the expression for, I hate this. What's this? We know this is WA from the first part, right? But what's Z1 though? Now, let's not look at it in terms of W. How do I get from A to Z1?
Minuses.
So A times by the negative angle, right?
Exactly.
Yeah? Instead of this, you actually might want to write it like this as well instead of the... Yeah? Multiply these two, you'll get A squared. It's not hard. Yeah? Like I said, it's nothing tricky. It looks tricky, but it's not. I won't do the third part. I think you guys are good. But what I did... so it says show that Z1, Z2 are the roots of this equation. So, what would you do? How would you go about it? Yeah. If you use quadratic formula, you'll get imaginary component. And once you get the actual complex numbers out, you'll find it's equal to that. Okay? So that's not hard. Oh, maybe I shouldn't have gone through this question. It just looked tricky when I went through it. All right, great. Last question, 35. Oh my God, so itchy. N plus 1 minus I n. So we need to show this. Okay? And it's only worth 4 marks. So it's not that hard, or it's not meant to be that hard. How would you do that? Look at this. Look at this. Oh, you can't expand it. Let's not expand it, right? Look at the form. It's so obvious, but I don't want to say it once I say it. It's like so obvious. Okay. This is all it is. That's all you need to access this question. Okay? Just because it's got a power doesn't mean you have to be scared. It's not going to bite. From here, well, what's the modulus? We got root 2. Yeah? And the angle, where is that? 1 and 1. Pi over 4? Is it pi over 4? Yeah, pi over 4. Yeah? And then if you raise it to the power of n. Yeah. So that's all you need to do to access this question. So that's that bit, plus this bit similarly. Yeah? And as you can see, if you add these two, do I have to expand and show you why it's cos and sine is taken out? Because you know with sine, if you have a negative angle, it's minus sine. So you got, basically, you can just write from here. Or not this, cos. Yeah, that's all it is. It just looks inaccessible. The question doesn't look accessible because it's, guided by the power n, but that's what it is. Hence or otherwise, show that, right. So in the second part, as you can see, we do need to actually expand it. Okay. Well, using binomial theorem, NC0 plus NC1I. Yeah? Next one would be minus NC2. Does that make sense? Because I squared. What does the question want? We need to plus them, right? So if I plus it, I'm going to get 2 NC0. Those are gone. I'm going to get minus 2 NC2. Those are gone. And we know that is equal to this. Now, look, from here, it's not too bad. What would you do from here? Yeah, divide them by... So all of this is like factorizing 2 out, yeah? And then, obviously, just cancel out the 2 with that. And then you'll get just this. And then from here, we'll look at the question. We've got this bit. We've got that bit in the question. But this... first of all, okay, what's n in the question? Read the question. It's right there. I can't just spoon feed you everything. You've got to interact with me here. Yeah, but what else? What does it say in the second part? Hence or otherwise show that every...
it's 4.
Yeah, it's divisible by... Yeah, so it's a multiple of 4.
Oh, so I cancel out 4.
Yeah, so what now? But hold on. If that was 8, now here's the part you got to know. If it was 4 here, you'll just get cos pi. That's is that
4 and 4 like something else.
Yeah, no, hold on. If it was 4, it'll be cos pi. What's cos 180? Is that 1 or minus 1?
Minus 1.
But if this was 8, you'll get 360. And what's cos 360? Sorry, 1, right? So from here is where you get plus or minus 1. But in what they want, first of all, can you see why they took minus 1 out of the bracket here, not the plus? Because if I write plus, you're never going to get the negative side to the answer. Right? If you raise plus 1 to any power, you're always going to get 1. So in order to get plus and minus, you've got to use minus 1.